And question 7 on this paper is the question they really like, this style of question about quadratic theory. And the thing to remember about this part of the question, it kicks off with a show that. That means that this is your end point for part A. Your start point for part A has got to deal with this theory and the fact the equation has real roots. Now, just before I talk a little bit more about that, the tricky marks in this question are the first 3. But if you fail on those, you've got a massive re-entry point here for part B. All you're doing in part B is factorising a quadratic expression into 2 brackets, easy peasy, and solving a quadratic inequality, which, as long as you remember to use a graph, should be easy peasy. The factorisation will give you the critical values. The graph, you'll be able to identify the bits you want. So your ranges of value of k, these last 4 marks are dead easy, and make sure you get those even if you miss out part A. Going back to part A, we know this is the end point. Your starting point is real roots, so you need to check in chapter 2 the thing that tells you how many roots a quadratic equation has got. It starts b squared. And to have real roots, b squared blah blah blah, has to be something in relation to 0, but there's a symbol that goes here. It's either greater than or less than, or greater than or equal to, or less than or equal to, or equals. Don't assume it's the same symbol that ends up in that equation. Ignore that really until you've got your starting point set up, but make sure you put a complete statement including the naught in. Then decide on your A, your B and your C values. Substitute them in. Keep this naught and the appropriate sign before it, and then stage your manipulation of that in easy stages. It's possible that during that the sign will flip, so don't be mesmerized by the way the sign's pointing on this to begin with. Work from the appropriate value of the discriminant, or range for the discriminant, and work through the algebra properly.